Hello guys, my name is Shubham Atmane. Welcome to my channel TedNetworking. So today we are going to discuss OSI model and TCP/IP model. So let's start with OSI model. So OSI is Open System Interconnection. So what is OSI? OSI model is a guideline for vendor to follow for making and working their devices according to the OSI model. So the first point is OSI is a reference model. It has 7 layers, each work on each work separately and it's used for establish communication between two devices sorry between different devices. So this is a overview about OSI model. Let's see how the OSI model look like. layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, and layer 1. So the first layer is physical, second is data link, third is network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer, and the seventh is application layer. So the OSI model divided into two parts, and so these are the upper layers or software layers, lower layers are hardware layers. There are so many ways to remember this OSI model. So from that, I suggest you one, and that is please do not take sales person advice. P for physical, D for data link, N for network, T for transport, S for session, P for person, and A for advice. In this way, you can remember this OSI model. So let's start from application layer. Before that, I want to give you some idea about router, switch, and hub. So on L3 layer, router work. On L2 layer, switch work. On L1 layer, hub, cables, and cable work. So let's start with application layer. Let's start with application layer. It's a seventh layer of OSI model. It's also called desktop layer. The work of this layer is to provide interface to user. Protocol comes under this are DNS, SSH, Telnet, TFTP, FTP, HTTP, HTTPS, DSCP, PC. So these are the protocols comes under application layer. Before going to another layer, I want to tell you our as a network engineer we have to work on layer 4, 3 and 2, 1. So the above upper layer is for software developer. So our main focus is on transport layer, network layer, data link layer and physical layer. So let's start our another layer, that is presentation layer. It's a sixth layer of OSI model. Work of the layer is to provide proper format to file or data. Compression, decompression, coding, decoding, encryption and decryption performed in presentation layer. Examples: JPEG, MPEG, MIDI. So our next layer is session layer. It's a fifth layer of OSI model. It's provide different session for different work. So For this, let's generate session ID and according to that session ID will differentiate the data, or you can say work. NetBIOS SQL. These are the examples which work under session layer. In this, the port number is used. It's a 16-bit value. So 2 to the power 16 is equal to 65,536 port, and the range is start from 0 to 65535, and the and port divided into three categories: 0 to 1023 well-known port, 1024 to 49,500, 49,151 are registered port. From 49,152 to 65,535 are dynamic private port. So, so for your basic knowledge, FTP use 20 and 21 port, Telnet use 23, SSH use 22, DSCP use 67 and 68, HTTP use 80, HTTPS use 443, DNS use 53, TFTP use 69. So our next layer is transport layer. It's a fourth layer of OSI model. It's provide end-to-end connectivity. Identification of service. So there are two protocol, TCP and UDP comes under this transport layer. TCP means transmission control protocol and UDP means user datagram protocol. So difference between in TCP and UDP. So the first point is it's a connection oriented connectionless. Second point is send acknowledgement, no acknowledgement. Third point is reliable, unreliable. Fourth point is slow, fast. Port use 6, port use 17. So under TCP, DNS, Telnet, SSH, FTP, SMTP, HTTP, HTTPS protocol comes under this TCP. And in UDP, DNS, TFTP, DSCP, SNMP protocols comes under this UDP. So you're wondering in DNS, I use DNS two times, but the DNS use both this TCP and UDP service. So in TCP, three-way handshake perform to establish connection. Sync, sync plus acknowledgement and acknowledge. Suppose this is IP1 12.1. Don't confuse 1.1, 12.1.1.2. So when user which have IP 12.1 want to communicate with 12.2, so the and it's using a TCP service, so the first sync packet goes from 12.1 to 12.2, and after that 12.2 send sync packet with acknowledge package to 12.1. Then again 12.1 send acknowledge package to 12.2. So when 12.1 sends sync packet to 12.2, so in the name of acknowledge 12.2 sends sync packet plus acknowledge package. Then again 12.1 send acknowledge package that by saying he get your sync package, so he sent acknowledge package. So this process is known as synchronization. In UDP, there is no virtual connection, no acknowledgement. In transport layer, segmentation performed. So what is segmentation? To divide a large data into small segment is known as segmentation. So the max segment size depend upon interface of a device. So the next layer is network layer. It's a third layer of OSI model. Router work on this layer. Connectivity between devices also check in this layer. IP address work on this layer. So our next layer is data link layer. It's a second layer of OSI model divide into two parts. First one is Mac. Mac means media access control, and the second is LLC, logical link control. The third point is LLC contain extra information of layer 2 protocol. MAC address. So the MAC contain the MAC address of devices. So the protocol works under data link layer is ARM, HDLC, CDP, STP, etc. I forget to tell you protocols works under network layer. So network layer protocol. ICMP, IPv6, RIP, IGMP, etc. So our next layer is physical layer. It's very simple. The work of physical layer is to convert frame into bits as 10101001 binary. It's layer 1 of OSI model. So this is all about OSI model and the working of OSI layers. And this is all about OSI model. Let's see encapsulation and decapsulation. So encapsulation means to add info on data by each and every layer in OSI model is known as encapsulation. And the decapsulation means to removing of info from physical layer to above layer one by one by removing headers is known as decapsulation. So I want to show you how the encapsulation and decapsulation perform. So let's visit my blog. So when the computer send data, so in this way encapsulation perform. First, data go from application layer, presentation layer, and session layer. Then from transport layer, the TCP header add. Then after that, IP header add. Then the data link layer header add with FCS. FCS means frame check sequence. Then after that, this information converted into binary and sent through the cable. So see, when users send data from one PC, in this way the encapsulation performed by adding header by header on each layer. Then after that, when the data, the information arrive on another device, so the decapsulation performed by removing one by one header. So from after that transport layer, the the data goes to application layer, from session layer to presentation, then application. In this way, encapsulation and decapsulation perform. If you want to read about this in detail, then I suggest you For more detail and self-study, you can use book ICND 1 and 2 by Cisco. But and second one is CCNA by Todd. So my personal suggestion is go with CCNA by Todd Lamley. In this book, you will get a way in this book you can find each and everything in simple manner. So it's easy to understand for beginners. I can show you that book. So this is the CCNA routing and switching study guide. This is your course divided into two parts, ICND 1 and ICND 2. So the next one is TCP IP model. OSI model, TCP IP model. Application, presentation, session, transport, network, data link, and physical. So in this TCP/IP model, the above three layer replaced with single application layer. Second one is transport. Third one is internet or network. And the last one is network interface. So the above three layer replaced with application. Transport layer same as transport. Network layer is become internet or network, and data link and physical layer both replaced with network interface. For brief information, you can visit my site tednetworking.blogspot.in or .com. You can visit here and check all the information related to networking as a brief history. If you want interested in history, you can read here. So basically, the TCP comes in 1973, and in 1978 it was divided into two protocol TCP and IP, and in 1983 TCP/IP replaced the NCP, that is Network Control Protocol, and the OSI model is. So in late 1970s, the Open System Interconnection, that is OSI reference model, was created by ISO, that is International Organization for Standardization. So here you can read all the details about OSI and TCP model. That's it for today. If you like my video, please like it, share it, and subscribe it. Thank you.